Today on Sci Guys, Gay-Lussac's Law.
Welcome to Sci Guys. I'm Ryan.
And I'm Adam, and today we're doing Gay-Lussac's Law of Ideal Gases.
You're not Adam. You're a girl.
No, I'm Adam.
I'm confused.
Gay-Lussac's law states that the temperature and pressure of an ideal gas are directly proportional. This means that as the temperature increases, the pressure increases, and vice versa.
The equipment you're going to need for this episode includes a couple of candles,
A beaker or glass,
some water and a shallow dish to hold it in,
some food coloring,
and a butane lighter or matches.
Although we're not dealing with anything particularly hazardous in this episode, it's always a good idea to wear an apron or lab coat to protect from spills and splashes. As well as our younger viewers, always make sure to have adult supervision anytime you're dealing with fire. So what we're going to do first is fill our shallow dish with an inch or two of water. And then we're just going to add some food coloring to make it easier to see.
The next step in our experiment is to take your two candles, place them in the center of the water, and light them with the butane lighter. For the final step, take your beaker or large glass and place it over top of the candles. After a little while of having our beaker over our candles, you'll notice the candles' flames will get smaller and smaller until they're extinguished. If you watch closely, you'll see that the water level underneath our beaker begins to rise as the candles fade away. The water level will continue to rise for a short time after the candle has been fully extinguished. You'll notice that the water underneath the beaker is much higher than the water in the shallow dish. Let's look at this experiment a little closer. Gay-Lussac's law states that when a fixed amount or mass of an ideal gas is kept at a constant volume and in a closed system, then its temperature and pressure are directly proportional. What this means is that when a gas's temperature increases, its pressure increases, or as its temperature decreases, its pressure decreases. As we mentioned in our last episode, an ideal gas is a theoretical gas composed of a set of randomly moving, non-interacting particles. Under normal conditions, many gases such as oxygen, hydrogen, and some heavier gases like carbon dioxide will behave like an ideal gas. This means they follow the laws of gases such as Gay-Lussac's law. In our experiment, our beaker is filled with gaseous air molecules. The energy from our flames transfers to the air molecules, exciting them by raising their temperature. When the air molecules in our beaker are excited, they try and spread further apart, but because our beaker won't expand like a balloon, the volume of space our air molecules can take up is limited. As they try and expand in volume, the air molecules press harder and harder against the walls of our beaker and the water at its base. This increase in air pressure under our beaker causes the water level under it to be pushed lower than the water level outside of it. The higher the temperature or the more energy the air molecules get, the more pressure will be created under our beaker. As the candle flames burn, they use some of the oxygen contained in the beaker for combustion. The products of this reaction are carbon dioxide gas and water vapor. As more and more hot carbon dioxide gases and water vapor are produced, they fill up the top of our beaker, forcing the oxygen in our beaker that the candles need to burn lower and lower until the candles are extinguished. Once the flame is extinguished, the air molecules under our beaker begin to cool off, dropping in temperature and losing their excitement. This causes the amount of pressure our air molecules are exerting on the sides of our beaker and the water at its base to drop. As the pressure drops, the air under our beaker wants to be equal to the pressure outside of our beaker. This need for balance causes a pull on the sides of the beaker and the water at its base. Because it's much easier to pull water into our beaker than it is to collapse the sides of our beaker, the water in our shallow container is pulled into our beaker, raising the water level under the beaker, equalizing its pressure. By changing the temperature under our beaker, we can clearly see the directly proportional relationship between the temperature and pressure of an ideal gas. This relationship is known as Gay-Lussac's law.
That's it for Gay-Lussac's Law of Ideal Gases. Thanks for watching.
If you enjoyed this episode, let us know in the comments below and subscribe for future episodes.
And be sure to like us on Facebook and follow us on Twitter.
If you have any questions related to this episode, or about science in general, let us know in the comments below or message us on Facebook and we'll try to help you out as best possible. Thanks for watching. Bye!
Bye!
You're not Adam, you're Teresa. You can't fool me.
Good job. You got it.
Here at Sci Guys, we're always curious how experiments turn out. So if you do these experiments at home, share a video or photo of them with us on our Facebook or Google Plus page. But remember to always ask your parents' permission before you share any photos or videos.